This is the reaction in which ammonia, NH3, is formed. Notice ammonia is not 2NH3. Ammonia is NH3. The 2 just tells us the ratio between the different substances in this particular reaction. So the formula of ammonia, NH3. How do we form ammonia? We react hydrogen gas, H2, with nitrogen gas, N2. In what ratio do they have to react? You need 3 molecules of hydrogen, shown here, 1, 2, 3 molecules of H2, for every 1 molecule of nitrogen, N2, and that will form 2 molecules of ammonia. But of course, when you actually react hydrogen with nitrogen to form ammonia, there's no way you're only going to react 3 molecules of hydrogen, like shown in this picture. You're going to actually react millions and billions and trillions of them, because they are so small, even if you react a little bit, it will be very many. So this is just a ratio. 3:1:2. It doesn't mean the actual number. And we use this fact to solve problems about this equation. The first step when you're given a question about a reaction is to make sure you have a balanced equation. Let's check that it's balanced. So on this side we have 6 H atoms, 1, 2, 3, 4, 5, 6. And at the end we also have 6 H atoms, 2 times 3. 1, 2, 3, 4, 5, 6. Hydrogen atoms have not been created or destroyed. All of those that were there in the beginning are there at the end. That's good. What about nitrogen? Here we have 1 times 2, 2 nitrogen atoms. And at the end, we also have 2 times 1 there, 2 nitrogen atoms. Nitrogen has not been created or destroyed. Everything that was there in the reactants is still there in the products, just rearranged with different partners. Okay, that's the first step. We check that we have a balanced equation. Yes, we do. So we go on. We now give the reacting ratio. We're going to give it in many forms. When you're answering a question, you actually only need to give the reacting ratio in the one form that's useful for your question. But let's say maybe you don't know that right now, so let's just work it out for many forms. 3 moles of hydrogen is to 1 mole of nitrogen is to 2 moles of ammonia. That is also 3 molecules is to 1 molecule is to 2 molecules, but let's write it in full. 3 times 6,02 times 10 to the power 23 molecules of hydrogen is to 1 mole, which is just 6,02 times 10 to the power 23 molecules of nitrogen, is to 2 moles, 2 groups of 6,02 times 10 to the power 23 molecules of ammonia. Mass. We ask ourselves, what's the mass of 3 moles of hydrogen? Each mole of hydrogen has a mass of 2 grams, so 3 moles has a mass of 3 times 2 grams. 6 grams of hydrogen is the mass of 3 moles of hydrogen. What is the mass of 1 mole of N2? N's molar mass is 14, so N2's molar mass is 28. What is the mass of 2 moles of NH3? 1 mole of NH3 has a mass of 14 for the N and 3 times 1 for the H, which makes 17. 2 times 17 is 34 grams. 2 moles of ammonia have a mass of 34 grams. So let's now write the volume ratio at STP. 3 moles of hydrogen, what is their volume? 3 times 22,4 decimeters cubed. 1 mole of nitrogen at STP has a volume of 22,4 decimeters cubed. 2 moles of ammonia at STP have a volume of 2 times 22,4 decimeters cubed. So now there we have our equivalent amounts. All of these refer to the reaction of hydrogen with nitrogen to form ammonia. So for this particular reaction, any pair of these can form a conversion factor, because for this reaction they are equivalent. How many moles of nitrogen gas? Immediately when we see nitrogen gas, we know we're speaking N2, not N, are needed to fully react with 5 moles of hydrogen gas. Again, hydrogen gas, H2, to form ammonia. So that tells us we can use these equivalent values which we've previously worked out. So why don't you pause the movie while you determine what conversion factor is going to be useful in this case. We need moles of hydrogen at the bottom to cancel mole hydrogen out. We need moles of nitrogen at the top to introduce that new unit. So we need a ratio in which they react, which gives how many moles nitrogen to how many moles hydrogen. And there we have it. 1 mole nitrogen from every 3 moles hydrogen. So if you don't have 3 moles hydrogen, but rather 5, then how many moles nitrogen do you need? 5 divided by 3, which is 1,67 moles of nitrogen gas. How many molecules of hydrogen gas are needed to react fully with 2,9 moles of nitrogen gas? Obviously according to this equation. So we can use the reacting ratios as our conversion factor. What kind of reacting ratio do we need in our conversion factor? Well, we must have mole of nitrogen gas at the bottom, and we must have hydrogen molecules, not moles, at the top. So here we have hydrogen molecules, and there we have moles of nitrogen. 3 moles, which is 3 groups of 6,02 times 10 to the power 23 of hydrogen react with every 1 mole of nitrogen. So if you have 2,9 moles of nitrogen, how many molecules of hydrogen do you need? 2.9 times 3 times 6.02 times 10 to the power 23. 5,24 times 10 to the power 24 hydrogen molecules. What mass, how many grams of hydrogen gas is needed to react with 15 grams of nitrogen gas to form ammonia according to this equation? Can you see the conversion factor we must use? We need grams of nitrogen at the bottom. We need grams of hydrogen at the top. So this is a mass-mass reacting ratio between hydrogen and nitrogen. 6 grams of hydrogen needed for 28 grams of nitrogen. So how many grams of hydrogen when you have 15 grams? 15 grams of nitrogen times 6 divided by 28 is equal to 3,21 grams of hydrogen gas. What mass of ammonia? How many grams of ammonia? So we already know that grams of ammonia is relevant here. Is formed when 50 decimeters cubed of hydrogen at STP. So we know that the volume of hydrogen at STP in this ratio is important. Reacts with sufficient nitrogen according to this equation. So we need a conversion factor with decimeters cubed of hydrogen at the bottom, grams of ammonia at the top, 34 grams of ammonia for every 3 times 22,4 decimeters cubed of hydrogen. Can you see that once we have this table correct, then answering these questions are very easy. So it's very important to understand how to get that table correct, those ratios. 50 times 34 divide by 3 divide by 22.4 is 25,30 grams of ammonia. Now just notice that previously I said that you can give the mole, molecule, and volume ratios all in the same form, and that's true. For this reaction, that is 3:1:2, because we could simplify this molecule ratio by dividing through everything by 6,02 times 10 to the power 23, and then we get 3:1:2. Similarly, we could simplify the volume ratio by dividing through everything by 22,4, and then we would get 3:1:2. The mass ratio is the odd one out. It's not 3:1:2, it's 6:28:34 in this case. However, when you're answering questions in the way that we are doing here, in order for this table to have equivalent amounts that everything refers to the reaction of hydrogen and nitrogen to form ammonia in the same way, that we are referring to the same quantities throughout our table, we must not give the molecule and volume ratios in their simplest form, because then we would end up with values that are not equivalent across the various parts of the table. So that's why we must give everything referring to 3 moles hydrogen over here, and everything here must refer to 1 mole of nitrogen, and everything here to 2 moles of ammonia, then everything is equivalent. Try answer this question yourself from the beginning before I help you. How many moles of hydrogen gas, so we see that moles of hydrogen is important here, are needed to form 30 decimeters cubed of ammonia at STP? So volume of ammonia here is important. So our conversion factor is a mole hydrogen volume ammonia ratio for this particular reaction. Decimeter cubed ammonia at the bottom, mole of hydrogen at the top. They react in the ratio 3 moles hydrogen for every 2 times 22,4 decimeter cube ammonia at STP, 30 times 3 divided by 2 divided by 22.4, 2,01 moles of hydrogen gas.